Alright, so a ball with a mass of 5 kilograms is moving at 4 meters per second, and it hits a ball of putty with a mass of 4 kilograms. The ball of putty was standing still before the collision, and they stick together when they hit. What is the velocity of the two objects after they collide? So, I know I told you before that you have to draw really good diagrams for the momentum. This is why. Okay? We're going to draw a really good diagram for this. So first we have a ball, okay? And it has a mass, we're going to write the mass is at the bottom of 5 kilograms. And it's moving at 4 meters per second. And that is going to hit, we'll just say that's putty. And the putty also has a mass of 4 kilograms. Okay, so this is the before diagram. The ball is moving to hit that. The after diagram, so we have, we'll just say this is the ball, and this is the putty. And they're stuck together, and they're still going to be moving that way. They're both moving the same direction, or one's not moving, one is. When they hit each other, they stick together. They're going to be moving this way. Okay, remember, the ball still has a mass of 5 kilograms, and the putty still has a mass of 4 kilograms. And the question is, how fast or how many meters per second are these guys going to be moving? So what we're trying to solve for, and I wrote a question mark meters per second here, is what's the velocity of the two objects after they collide? Alright, so it does not matter which object is M1, or which object is 1, or which object is 2. You can pick either one. So I'm just going to use the first object as 1, the second object is 2. Doesn't matter. So the mass of the first object, we know it's 5 kilograms, a ball with a mass of 5 kilograms, so I'll write 5 kg right there. And then velocity 1, so the velocity of that object is 4 meters per second, so I'm going to write 4 meters per second. Alright, and that's hitting something, and it says, let's see, so the mass of the ball of putty is going to be 4 kilograms, so I'll write that there, 4 kilograms. And then the velocity of the putty, so it says in the second sentence, the ball of putty was standing still before the collision. So if it's standing still, it means it's at rest, has a velocity of 0 meters per second. Okay? Alright, so we can do this step really, really easily right here. We can find our total mass. So I want to add 5 kilograms and 4, 5 plus 4. The total mass of this is going to be 9 kilograms. Okay? And so the total mass is going to be 9 kilograms. And I don't know the velocity yet because I'm trying to find that. So I'm just going to write a question mark there for now. Alright, plug in values. We had M1 V1 plus M2 V2 equals MF VF. Final velocity, final mass. Let's plug them in. So my M1 was 5 kilograms. Okay, my V1 was 4 meters per second. So 5 kilograms times 4 meters per second. And then plus my second mass was 4 kilograms. And then my second velocity, since it wasn't moving, it was at rest, is 0 meters per second. Okay? And then I know my final mass, so that's going to equal my final mass, which is 9 kilograms. But I don't know my final velocity, so I'm going to leave that as V sub F. 9 kilograms times V sub F. You cannot forget that it's multiplication there. That will be very important later. Alright, solve for answer. Alright, so let's combine some of these as we go. So 5 times 4 is what? Okay, 5 times 4 is going to give me 20. So I'm going to have 20 in that first. And there'll be kilogram meters per second, because we're combining kilograms and meters per second. And then plus, on this side I've got 4 times 0. What's 4 times 0? 0. kilogram meters per second. And on the other side, I still have 9 kilograms times final velocity. So 9 kilograms times V final. Alright, so 20 plus 0, what do I have left on this side of the equal sign? Okay, 20. And we're going to, so 20 kilogram meters per second. And then on the other side, I still have 9 kilograms times my final velocity. Alright, so we want to get our final velocity by itself. So what do I have to do with this 9? I have to divide both sides by 9. So divide this side and divide this side. So 9 on this side and 9 on this side. And it's not just 9, it's 9 kilograms. And that's really important because that'll give you the correct answer in the end. Alright, so 20 kilogram meters per second divided by 9 kilograms. 9 kilograms divided by 9 kilograms. So 9 kilograms and 9 kilograms, both kilograms cancel out. And the 9s also cancel out. And then I'm left here with 20 kilogram meters per second, 9 kilograms. So I can actually cancel out these kilograms and these kilograms too. So now I'm just left with, and I'm going to rewrite it over here where it says answer. So I'm left with on this side 20 divided by 9. And on this side there's only one thing left, which is the VF. So I'll do this. And I'm going to make a box here so this is separated out. So 20 divided by 9. And there, it's 20 meters per second, mind you. Equals, and that's the VF. Now we've just got to do our division. 9 goes into 20. Let's do that over here. So let's see. 20 divided by 9. 9 goes into 20 2 times. I get 18. I get 2 again. If I add an extra 0 after that, I'll have 20. 9 goes into that 2 times. Guess what? It's going to go on forever and ever and ever. So I'm going to put 2.2 with a line over it. So my final velocity, and I've even got my units right here. So VF equals 2.2 meters per second. I'm going to put a big box around that because there's a lot of numbers there. And I feel like that could be confusing.